Okay, it is the morning, and that means it's time to learn. Hello. Oh, okay, that's still good. Hello, YouTube. YouTube. I have had a question asked to me about dynamic memory allocation, so I'm going to answer it. It says, if you do another one of these, I would like a bit more of an explanation of all the memory stuff. Dealing with things like the stack, heap, pointer, addresses, and free memory are what makes these scary to me. And if you can break down how you deal with all that stuff, I think it would be quite interesting and helpful. So now we're gonna start a new project about dynamic memory allocation. Am I recording? Yes. Okay. It's gonna be fast. It's not gonna be a long video. Um, main.c. So let's go over the stack. Dynamic. And I put all these on GitHub, which I will link this one after I'm done with it when this video's done. Um, so you need stdio for standard input library, and then you need the standard lib, which includes malloc and free, which we need for this video, and main no arguments return 0, and then okay, let's go over dynamic memory allocation. So when people talk about the stack, they mean memory that's pre-allocated and that doesn't have to be allocated at runtime. So for example, if I do floats, um, numbers, and I allocate uh, 4 integers, and I say 3.14, uh 0.69, 4.20, and 69.69, then all of these numbers are allocated. And so if I wanted to just like print out some of these numbers, is um LF is in the index. So numbers dot two, so in the second index. And then if we go and compile that, so cc wall error main.c, and then the output file is main. Oh, save it, and then main. Oh, if you do, I forgot how to do the format specifier. I think it's like point true, and then okay, yeah, I don't remember. Okay, but Yeah, this is stack allocation. When you have a predetermined amount of numbers and it just um yeah, you have a predetermined amount of numbers. Next, let's look at things that are heap allocated. Uh, let's make let's make a multiplication number list. So let's say ints pointer numbers. Say we want to print something. Printf, please enter how many numbers for the new line. The multiplication table. And then we do scanf. We need a variable first. Use a format specifier %d for int. And then we do the address of inputs. So now when we malloc numbers, we can do inputs times the size of ints. Size of ints. No, I don't think. Oh wait, I didn't even write malloc. Okay, there you go. And then after that, we're gonna fill up. So do int I equals 0, I is less than inputs less than or equal to inputs I plus plus. And now we're gonna put printf. So let me put a title. Allocation table for inputs. So we're gonna do d times d equals um, how many numbers for the multiplication table, and then the second printf is going to be of what number to multiply by. And then scanf again. And it's multiple 0. So we would have multiple, and I is equal to multiple times I. And then, so this is how we allocate memory to the heap. Oh, unused variable. Oh, wait. Oh, wait. Okay, so let's go over it. We have an input, so how many numbers long we want the multiplication table to be. We have the multiple, what number we want it to multiply by. So we take the input and times it by the size of however many integers, and that will give us our array of numbers that we're gonna use. Now we need to fill that array and say numbers plus I is equal to um multiple times I. And this has to be less than, if that's the case. And now, how many numbers do you want? Let's say 5. What number do you want to multiply by? Let's say 5 again. Oh, wait. Let me see if this does it right. Let's say 5, 5. Okay, yeah, that works. So we compile. we execute the program. So say we want 10 numbers and we want to do the number 5. So it goes from 0 all the way up to 45 or 9 because it's 0 index. And this would be heap allocation. Um, Now let's talk about pointers too. Yeah, let's talk about pointers. Let's talk about how pointers and arrays are the same thing, basically. Or they're not the same thing, but let me show you. Instead of going like this and um, or let me just explain this part. When you have numbers plus I, when you add a number to I, it moves the amount of slots. Um, so say I wanted to do number 3, and then I compile this again. Swing. So say we do 10, and we're gonna get the fourth index of this, and then we do 10. So it's gonna put 30, which is number 4 on the ladder for multiplication table. But you're like, oh, um, damn. Oh, why does it do that? When you add a number to a pointer position, numbers being the pointer, if you allocate memory for the space, you can go to that spot by adding the number to the pointer, and it'll bring you to that spot. Like let me show you a different example. Okay, there we go. Okay, next. Okay, addresses. let's say we have int num pointer is equal to numbers. Just like we can do numbers plus I, you can still use the same array index. And you can do like numbers 2. And then you can put printf num pointer address is going to be equal to p. And then the num pointer value is going to be equal to %d. So you have num pointer as a name by itself will give you the address. And then if you add the asterisk and you dereference, it'll give you the value. So now if we compile, oh wait, I need to put a parentheses. Okay, I don't know why it's doing that. Let me check something. Oh, okay, I get it now. Forgot to use the pointer. I forget little things like that. And see, it points to the second value. Okay, our next thing is freeing memory. So we allocated memory. So we always need to free it at the end. So we need to free numbers and we need to free num pointer because we did use it. Actually, no, you only need to free things you allocated memory for. So just numbers. And then numbers will be null. If numbers check for equal to null, printf numbers is null. Okay, no, I don't think that's how it works. I think it's not numbers. No. That's okay. I think I explained it enough. But yeah, uh the stack uh, the stack is just numbers that are already allocated at compile time, like the program already knows what it is. Next, we allocated numbers to the heap. We got our input and the multiple. We allocated as many numbers as we needed for the input for numbers. Then we filled that array of numbers that we allocated with malloc, and then I'm coming, cutting the video, and then we printed out those numbers, and then we grabbed a pointer to one of those numbers, and we displayed the address and the value, and we got the second slot or the third slot for this in this matter. So when you do numbers plus 0, you're getting the initial slot. Numbers plus 1 is the second one, and numbers plus 2 is the third. So that's why when we do 5 and then 5, where we get the num pointer, we get 10. That would be the third slot. Oh, let me remove this actually. And then make this 0. So we do 5 and 5. 10 would be the third slot. And that's how I think about memory and allocation. There's more advanced ways to use memory allocation and stuff like that, but I'm still learning. And that's the video. Thank you.